Good day, folks. I hope everything's going well for y'all. Today we're going to go through, and it won't take us very long, questions 1 through 9 in section 4.2 in your workbook. That'll incorporate the problems on pages 139 through 141. Now, explaining the hand rules when you're in person is really difficult, and it's kind of hard to gather at first. So we'll make the best of it, and you're going to understand it or not understand it as well as you do, and it's not going to hurt you too much in life, so we'll be good about it. But we'll work through this 4.2 and get a little bit better idea, hopefully, after we're finished. So let me tell you about a good Danish fella who was from Denmark, and his name was Hans Christian Ørsted. And he was setting out to prove there was no relationship between electrical current, electron flow, and magnetism. So he designed an experiment where he took a wire and he ran the electrons through the wire. So in this case, it's going from the left side of the page to the right side of the page. And he started off and he took a compass and he placed a compass underneath. And when he observed the compass needle in that position, he found it kind of went. It should be an angle. It's hard to do these in 3 dimensions, but basically the arrow was pointed kind of like that on the compass. So then he took that compass and he moved it up above into that position there. Much to his surprise, the compass needle, come on baby, reversed direction 180 degrees, pointed the other way. And what he came to realize by accident, trying to prove the opposite was true, that when you have electrons, electricity flowing through a wire, a magnetic field was placed around that wire. So the direction of the magnetic field is shown in this diagram. We'll show it again later, but basically it works like this. This is the first left-hand rule. And it's very important that we use our left hand simply because we're dealing with electron flow. So electron kind of sounds like starts with L, left starts with L. So whenever we're talking about electron flow, we use our left hand. Now, we don't study it in high school anymore. We used to in the old days, we don't anymore. Something called conventional current. And conventional current is the flow of positive particles through wire. It doesn't really exist, but it can happen with positive particles moving through a solution or a molten state, so it can actually happen. But the Americans even though they know better, they play with the conventional current. It's also studied in the IB and the AP program. So let's say per chance that you were in an exam and you had broken your left hand and you can't go ahead and use it. The current would be going in the opposite direction, and then you just use your right hand. It still comes out the same way. So with the first left-hand rule, later in this exercise, we're going to go to the second left-hand rule, and then tomorrow we'll do the third left-hand rule. On the first and the third, your thumb is the direction of the electron flow. On the second, your fingers actually are the direction of the electron flow. So it's a little confusing that way, but for the first hand rule, so our thumb is always going to be the electron flow direction. So in this case, best thing to do is grab a pen or a pencil, place in your hand, pretend it's the wire, and then put your thumb in the direction of the electron flow. If you look at the way your fingers now curl around that pencil, that's the direction of the magnetic field. So the magnetic field is always going to be coming out of your fingertips, but it'll be going around. So in this case, just get this out of the way here. If we look at this area right here, the magnetic field would be going in that direction. When we go to the bottom, it's wrapping around, it's going to be coming kind of in that direction. In this point right here, magnetic field is upwards, and if you want behind it, it'd be going downwards towards the bottom of the page. So at the position right here, kind of coming out of the page, this place, going into the page, in front here, going towards the top, and behind it where we can't really see, it's actually going to towards the bottom of the page. So when it comes to drawing fields and lines and particles and stuff, when we talk about stuff going into the page, we tend to use this symbol right here, which is kind of like an X. The way I like to think of it is if you had an arrow and you drew your bow back and let it go, all you would see of that arrow as it's flying away from you is the X from the feathers at the back. So the X is going away from you. But if somebody else had shot an arrow towards you, all you would see is the sharp dot of the arrow coming towards you. So this is going to be coming out of the page towards you. And this is going to be into the page, away from you. Other conventions we can use, it's always really good when you're explaining things is on your paper, go north, south, east, west, and then going into the page would be, again, an X, going into the page or coming out of the page, or the board in this case. So again, the first left-hand rule. We use the left-hand rule anytime we're talking about electron flow. And be symbolized by an E, showing the direction, usually with an arrow like that. The thumb of the left hand points the direction of the electron flow. So your thumb is that direction. So if you can see in the direction here, and the fingers that circle around, the fingers then, the way they circle is the direction of the magnetic field. A cheat that I would sometimes tell kids to do, can't walk into the exam with the little arrows on your fingers, but while you're there, you can draw just little arrows at the tips of your fingers, right on your fingernail. Unless you have them all gussied up with those fancy press-on nails or whatever people get these days. And just rotate your hand then around the wire to show the direction. And those fingers point towards it. So the electron flow is going from here up to there. So that would mean that if we had this set to a battery, the electrons are going to go to the positive end of the battery. They would have come from the negative end of the battery. So we're going to be using that convention coming up here pretty soon. All right. So that's the first left-hand rule, and it shows the magnetic field. So again, if we went to a point in front, so this is in front towards you, it's in this direction. If we were behind, back here, it would be the magnetic field would be in that direction. If you're at this point right here, directly to the side of it, it's going to be coming out at you. At this point, it's going back in. So this is the second left-hand rule. We'll get to those later on in the problems. The left hand grasps the coil. The fingers now on the second hand rule curl in the direction of the electron flow. And I always like to pay attention only to the very, very first finger or to your baby finger, whichever is the closest to what you're going to be looking at. Your thumb then points towards the north, and the butt end of your hand points towards the south. So since the electrons in this case were flowing around like this, that's the direction that the coil created a magnetic field. So this would be the north end of your magnet. Back here would be the south end. So on the second hand rule, the thumb is the north pole and the fingers are the electron flow. On the first hand rule, and you'll see later on the third hand rule, your thumb will always be the direction of the current, but not the second. Again, this is not going to be easy to understand from this format. It's not easy to understand on a good day. So here we're going to use the first hand rule. And so with the first hand rule, our thumb goes in the direction of the current and our fingers are in the direction of the magnetic field. So if you think of this wire, your fingers are going in front of it upwards and then wrapping around on your left hand. That makes your thumb pointing this way So the electrons are flowing that way. The electrons are flowing that way. So hold a pen or pencil in your hand, put your fingers and let them wrap them around there. Your left hand has to point so that your thumb goes towards the right. Question number 2. So we have the electrons going up now. So take your thumb and point it upwards, and your fingers then would wrap around so that they're moving around. So if you move your fingers so they're pointing around your pencil, coming out at you, the magnetic field is going this way, and behind it it's going around. So that's your magnetic field. Out in front, it's that way. Behind, it's going around that way. So that's behind. Out to front. All right. So that's the direction of the magnetic field in that case. This is a hard format to try and learn it at, folks, and I understand that. Again, I'm not going to evaluate this very strongly with you, so that's okay. In a regular class setting, we'd spend more time on it. You'd have a sense of it. We could pull out some gloves and play around with it a little bit. Watch that video again, the TV Ontario one, it might help a little bit. So on question 3A, draw the magnetic field around the wire. So you've got, in this case, you've got an X, which means that your electrons are flowing into the page. This north over here is not a magnetic north or south, it's just kind of showing what north direction is. So on this one, your thumb has to be going into the page. So if you take your left hand and you put your thumb in to the page, you'll find your fingers are wrapping around this way. So that's your magnetic field direction. So this diagram for double I here was really difficult to follow. So what I did was, well, I guess, sorry, on question 1, if that's the north end up here, this was the south end. And so for right the south, it's going in that direction, the way that I read the page. So what I did was I took away the arrow that was there, said this is the north side, this is the south side. Since this is the ground, what that means is that you're east of that wire, and west is going to be the direction behind the wire. So west would be back there, and up in front of here would be east. So in this case, you've got the electrons are going in a downwards direction. So take your left hand and point your thumb downwards, and then wrap around that wire. When you came to the south side, which is over here, that magnetic field is going to be coming out at you. So that would be the magnetic field there. At the point which is north of it, the magnetic field will be going into the page. Out in front at the east, it'll be going towards the right, which is towards north. And behind it, I'll draw it in blue so it's a little bit different. Behind it would be the magnetic field going towards the left-hand side, towards the south. Not easy to follow. Generally, the questions, when they did show up on a diploma exam, the drawings and the conventions were just a little bit easier to follow and to comprehend. All right, the rest of these kind of make a little more sense. So if the magnetic field here is coming out at you, just think about your left hand. If the fingers are curled out at that direction, that means your thumb is towards the top. So the electrons are flowing out at the top. The electrons are flowing in at the bottom. And then the same if you rotate it around to this side. If they're going, your fingers going into it, again, the direction of your thumb for the first hand rule is the direction of that flow. This one is exactly the same diagram, just they do the field instead of showing the directions of them. Fingers are wrapping around that way so that your fingertips are there out front. Here's out front. This is behind. That means the electrons are going out here. The electrons are coming up here. So again, if you're getting this, fantastic. If you're not, it's just icing on the cake anyway. So let's take a look at that. We've got a battery here. And the battery, this is the negative terminal, that's the positive, which means the electrons are flowing this direction. So you take your left hand around the wire right here, you point your thumb upwards. That's the direction of the electron flow. In that case, if you curl your fingers around, at the point P here, the magnetic field is going, your fingers are pointing into the page. So it would be drawn like that with an X to show the arrow going away from you. So there's your magnetic field at that position right there, number 5. So moving on to question 6, I decided to draw the diagram like this so that you are looking at it from above. So you're looking at it from above, and the wire, which is suspended vertically, has the electrons here coming out at you. All right, so that represents the electrons coming out at you. So then if you take your thumb, your left hand, your thumb points towards your face, that means above, you're going to have magnetic field in that direction. On the east hand side, your fingers are going to be pointing down. Wrapping around, it's kind of hard to do. Fingers are going that way. And on the west hand side, the magnetic field would look that way. So the direction of the magnetic field that point directly to the south down here is towards the left would be an acceptable answer, or in this case towards the west, based on the way we did our diagram. So a quick sketch like that, deciding on that is the easy solution to a problem like this. Question number 7. Now we're moving to the second hand rule. So right on this second left hand rule. All the questions before were the first hand rule. So now our thumb, instead of being the direction of the current, is going to be the direction of the North Pole. And our fingers are going to be the direction of the electron flow. So in this case, the electrons are leaving this way and going up. They're coming around that way, that way, that way, and then they come back this way. So what I like to do then, you take your left hand, and you always think about either your baby finger or your pointer finger. In this case, we're going with the baby finger because it comes first. So you take your fingers of your left hand and you wrap around behind that coil, your baby finger, which is going to be going up behind here. That causes your thumb to point towards the left hand side. That makes that the North Pole, and that the South Pole. In question number 2, now we have the electrons. This is the negative, this is the positive. So the electrons are flowing like this. Take my fingers to follow those electrons. They have to go behind. So in this case, I have to take my pointer finger going behind. My thumb, again, is off towards the left. Makes that the north, and that the south. So just hold something, a pen or pencil in your hand. Take your left hand, wrap them around. So in this case, where's the pointer finger going? It's going behind and then over the top. On the first one here, where was your fingers? Well, you had to take your baby finger because it was going behind. It's going behind and over, your thumb to the left on both of those. So north is on the left-hand side of both. The magnetic field lines around these guys, remember how they go away from north, towards south, and then around from north to south, around from north to south, away from the north, towards the south, that direction like that, that direction like that. Oops. Okay, so take this coil of wire now. Since this was identified on the right hand here as the north, that's the direction your thumb must be. So take your left hand and put your thumb. Now you can see that, again, we're going to concentrate on the pointer because it's the closest to the thumb. It's going in front of, which means that's the direction of the electron flow. It's going like this, wrapping around, and it's coming down like this. If that's the case, the electrons are going to flow over here to the positive terminal. They left the negative terminal. So there's your cell that you drew in for that one. Very similar to that on question 9, except what they're going to do is they're going to place, remember this is the north end, this is the south end. North end is attracted to the south end of a magnet. The opposite, this pole has to be at north. Taking your left hand, putting it towards the left-hand side, towards that north. How do your fingers wrap around from behind, going over the top, which means the electrons are going that way. And they're going to be coming back that way. That means that's a negative. And that's the positive. Now, I'm absolutely sure that that's about as clear as mud for you all today, but there's 20 minutes of your life you won't get back. Just look it over a couple of times. If you got it, great. If you don't sweat it. You won't be tested on it at all. A little bit here and there when we get to third hand row, but not too much for the first and second. Thanks, folks. Talk to you soon.